In this video now we will learn how to calculate integrals that involves logarithmic functions. So remember that when we defined the power formula, we had to avoid the case where n was equal to -1. So this logarithmic formula will tell us what to do in that case. So notice that this is the same as u of x to the -1 times the derivative of u. So this is covering the case where n is equal to -1 of the power formula. So what do we do in this case? Well, the result of this integral will be the logarithm of the absolute value of u. So maybe let's highlight this absolute value part, plus a constant. So in particular, if we want to compute the integral of 1 over x, then we can use exactly this formula because u would be our function x and its derivative will be equal to 1. So in this case we can use the formula directly, and now we know how to compute the integral of x to the -1. It will be the logarithm of the absolute value of x plus a constant. Let's see this formula in an example. So in this case we want to compute the integral of x minus 3 divided x squared minus cx plus 1 with respect to x. So notice that our best candidate for u should be the one on the denominator. So this one should be u. So if u of x is x squared minus 6x plus 1, then the derivative of u will be equal to 2x minus 6. So again, we don't have the exact derivative, but notice that they only differ by a constant. If I multiply this by 2, I get back my derivative. So this integral here can be rewritten as 1/2 2x minus 6 x squared minus 6 plus 1. And now we have all the pieces that we need to use the logarithmic formula. So we have our u, which is this one here, which is here. So the formula says now that this is 1/2 the logarithm of the absolute value, careful there, you need to include the absolute value, of x squared minus 6x plus 1 plus a constant. So always remember when we have the situation of a derivative divided by the function, then we can use the logarithmic formula, and always remember to include the absolute value.